Good afternoon, everyone. I'm Laura Romero. I'm a geologist studying at the National University of Colombia, and my presentation is called Mapping of Martian Geoforms as an Input to Construct an Analog Environment in Colombia. This is part of what I'm developing for my undergraduate thesis, supported by the CNF Foundation, a foundation that promotes space development in my country and that last year built the first analog station in it, RSC, where this work takes place. Well, on the surface of terrestrial planets such as Mars, there are characteristic geoforms, for example an impact crater, a lava flow, or a paleo lake. One of the projects that is being developed within RSC is to create a space called rock garden, which is an analog of these geoforms. But what does an analog mean? An analog is a situation on Earth that resembles what can be experienced in space. So the rock garden is a simulated environment that approximates a geological environment, collecting its fundamental features without the need to reproduce all its complexity in order to perform different tests. The idea of this project and of the station is to be simple, practical, and low cost. For this reason, several geological environments were analyzed and evaluated to see the most versatile and relatively easy to build. The preliminary result is a modular structure design with 5 separate modules with 2 different sizes. Depending on the morphology to be simulated, they will be filled with rubble, gravel, sand, cement, and other materials. However, a very important question is how and which of the features of the different planetary surfaces are replicated in the analogs. To identify those major morphology features, I selected a specific location on Mars for each of the geoforms to be built in a rock garden by reviewing a compilation of these geoforms in the literature and databases. The search and selection criteria were mainly based on them being representative with typical shapes and dimensions common on the planetary surface, as well as easy to identify and map. Having high-resolution images at a scale appropriate for general mapping was also very important. The idea is to create a map in each of the sites and identify units according to the characteristics of each environment. The geoforms that have been selected are the ones that I mentioned at the beginning. 3 2 by 2 meters bursts will contain a 1 meter diameter impact crater with an opening in this ring, lava flows with different viscosities and deposits, and a planar space that will function as a control terrain or a rotating stage. As an analog of the impact crater, I chose this, very simple, about 1 kilometer in diameter. It's almost perfectly round with some landslides, and based on this degradation, it seems to be very young. In the northern lowlands of Mars is located. And for the lava flow, one of the many flows on the slope of Olympus Mons. This is in the southwestern part of the volcano, and these are useful because the images allow the identification of flow fronts and the superposition of different volcanic events. The other 2 boxes will be 2 by 4 meters in size, one of which will be divided into sectors to simulate different types of terrain, and the other will represent a lay bed. As an analog, I choose this one within a 37 kilometer impact crater north of Valles Marineris. The delta associated with this deposit is visible in the south, and I found this one very interesting also because this very distinct albedo change. With this work, I hope to contribute to the mapping of the Martian surface, as well as developing this rock garden model as an integral part of the first Colombian analog station. Its scientific aim is to test protocols that optimize the operation of robotic and human extravehicular activities in a future space mission, and to improve its design and construction by evaluating its status. Please feel free to ask me any questions you may have, and thank you for your attention.